This is the video on neutralization and hydrolysis. So neutralization you may have heard of. When we think about it, we say it means like to destroy or to cancel out in chemistry. And hydrolysis actually means to add water. Specifically, if you break the word down, it's hydro and lys. Hydro implies water, and lys is like from a lysosome in biology. They are the things in the cell or the organelles in the cells that split the cell in half. So essentially you're taking water and you're breaking it up. That's essentially what hydrolysis means. The reaction is pretty simple. You take an acid and a base and you mix them together and you get salt and water. And now here's the reason why. The H from the acid and the OH from the base come together to make H2O, which is basically water. We just rewrite it as H2O, not HOH anymore. And then what's left over, the acid part of the acid and the base part of the base, they come together. I'm using A and B to represent them, but it's really chemicals or formulas. They come together to make a salt. So that's how it works, but we're going to get to the nitty gritty. You're going to have to basically be able to predict the right side of the equation. So when I take an acid and put it in water, we should know that acids give off H+. So HCl, when it goes in water, it turns into H+ and Cl-. Now they would both have a Q signs because they're dissolved in water. That's less important at this point because you should know that by now. And when NaOH goes into water, it breaks up into Na+1 and OH-. Now, I have noticed before when I've seen some people asking questions on our last video where we did stuff like this, students were not breaking up. They were breaking up things that shouldn't have been. Basically, if it's on table E, it's not going to get broken up. And so OH is on table E. It's a polyatomic ion. That's why I'm not breaking it up into individual O and individual H. It's also covalently bonded because it's two nonmetals, so they're not going to break up. That's part of the reason. Now, you put these in water, and look at what happens. The H and the OH are going to make water, and then what's left over is going to end up making a salt. So that's actually our first reaction that we're doing. So here, the H and the OH come together, and they make water every time. And then what's left over has to be put together to make an ionic salt. Now there's a couple rules. First I need to know their oxidation states, right? And the way I do that is, well, I have a rule for H, it's +1, so chlorine's got to be -1. Set this whole thing equal to 0, you can figure it out. And I know that OH as a polyatomic is -1, table E, so therefore Na has to be +1. Also, Na is in group 1, so it has its own rule. So now I'm going to crisscross these. So I'm going to write Na first, because general rule, we always put the positive ion first. And then I'm going to put Cl second, because it's negative. And then I crisscross them, and since they're 1 and 1, it would be 1 and 1. I'm not going to write it. We could go in and balance these equations after the fact. But for this equation, since everything's 1, the balancing is just going to be all 1s. So that's how you do it every single time. So watch, I'm going to do all of these with you. The H and the OH always make water. It does not matter that there's two H's here and that there's one OH here. When we balance it, we'll solve that problem. But when H and OH come together, they're going to make water, no exceptions. And then what's left over, in this case, Na, which is +1, that's all I really care about. And SO4 as a polyatomic, if I look it up, it's -2. Also, part of the reason there is two H's here is because if this were to be crisscrossed, a 2 and a 1, when I crisscross it, this 2 becomes the 2 in front of the H's, and then the 1 obviously isn't written down here in the bottom right-hand corner. That's why this formula is the way that it is. NaOH doesn't have it because they're both 1s. So now when I make the salt, I'm going to put Na first. Then I'm going to put SO4 second because it's negative. It should be -2. Then I'm going to crisscross them, and it's going to turn into Na2, and then SO4, I'll write it out, but you don't have to, 1. So that one is that one. Because it's a 1, I normally would drop the 1, and because I dropped the 1, I also would drop the parentheses. You don't have to if you don't want to. Now, in terms of balancing, these would have to be balanced to account for the fact that they're not equal. So I put a 2 there, puts 2 there, and then those are 1s. and it's balanced. So the fact that the H's and the OH's aren't equal, we fix that balancing later, okay? Next one, I'll go a little faster on these. This part's always going to be H2O, and then Mg and F are going to come together. Mg went first because it's +2. F is -1. Crisscross them, and there's my formula. And then to balance them, put a 2 there, 2 there, and then those are 1s. Okay. Last one. The reason there's 3 H's with PO4 is because PO4 as a polyatomic found on table E is -3 and H is +1. So when I crisscross them, that's what I get. The reason there's 2 OH's here is because Ca is in group 2, it's +2, OH is -1. When I crisscross them, that's the formula I get. It doesn't matter. You're always going to make water, and then what's left over has to be crisscrossed. So this 2 means I need 2 PO4s, and this 3 means I need 3 CAs. And then I could go in and balance it. This one, I guess, balancing it, I'd have to put a 3 there. I'd have to put a 2 there. That would give me 6 and 12 H's. So then that would be a 6 there. And then this would be a 1. So that's balanced. So that is neutralization. Now this is actually, believe it or not, hopefully you thought this was easy because this is the easy stuff. The reason it's easier is because the H and the OH always make water, no exceptions. What we're going to do now is essentially we're going to reverse it. So I'm going to give you the stuff on the right, which is a salt and a water, and then you're going to have to predict the acid and the base that it makes. So that's a little bit more complicated, but it's really not that much worse. So watch how it works. When NaCl goes into water, it breaks up into Na +1 and Cl -1. They're both AQ. When H2O, now it doesn't normally do this, but for this, the reason hydrolysis works is actually the NaCl, the salt, will cause the water to split, but we're kind of not saying that, but it's fine for this video. And only certain salts really do this. Some salts do it more than others. Again, it's a topic we're not going to get into, but here's how it works. The Na, since it's positive, is going to link up with the OH because it's negative, and the H, because it's positive, goes with the chlorine because it's negative. And now, how do we write it out? Well, here's the way I like to do it. I take my salt and I figure out which half is the positive half and which half is the negative half. I made the positive half's green, the negative half's blue. So since Na is my positive half, I'm gonna write it first. You don't have to. You could write it second. It wouldn't make a difference. So there's my Na +1. And then my chlorine is going to be the -1. The reason I know that, I assign the oxidation states, right? I'm going to put it over here and write it there. The reason I wrote Na first was because my positive always goes first, and my positive is going to go with the negative. The negative is the OH, okay? And since chlorine is my negative, I wrote it with a little bit of space because I knew ahead of time that I was going to have to put it with a positive, which in this case is going to be H. Okay, now I crisscross them. Luckily, OH is -1, and these are 1 and 1, so I don't have to do anything. And because of that, the balancing is all 1s, and that's how hydrolysis works. Now, it can get a little more complicated. We'll go over 3 more, and then that's pretty much it. So watch how we do this. The Mg is the metal, it's +2. Chlorine's -1 as a result. Mg is also in group 2, so it has a rule. So Mg goes first. Okay, and then I know chlorine, since it's negative, is going to go last, so I write it over there. Now, H2O is broken up into H plus and OH minus. The OH, because it's negative, goes with the positive, and the H, because it's positive, goes with the negative. They get crisscrossed, so now it's going to be MgOH2 as a formula, and then 1 and 1. Okay, and then to go back and balance this isn't too terrible. I'd have to put a 2 there, and then a 2 there, and then 1's there. So that's balancing. Okay, and that's how it works. Now, when I say it doesn't matter if Mg goes first, I want Mg to be before OH. But what I mean is MgOH2, it can be written as the first compound in the reaction, or it could be here and HCl could be first. But it's always going to be H with Cl, H first, Cl second because positive and then negative, and Mg first with OH minus second because positive and then negative. But these two chemicals don't actually matter what order goes first or last on the right of the arrow. It could be this equals HCl plus MgOH2. It could be this equals this and this. That won't matter. Next one, AlI3. So Al is plus 3, I is negative 1. That's why they're crisscrossed this way. So when I put them together, Al is going to go with OH because positive goes with negative, and H is going to go with the I because positive and negative. Now again, a common mistake I see is because there's 3 I's here, a lot of people want to put 3 I's here. That's not how it works. Each compound has to come together to become stable. That's what the crisscross method does. So since Al is plus 3, OH is minus 1, when I crisscross these, I get that. And since these are 1 and 1, they just stay HI. And then to go back and balance, let's see, 3, 3, and there we go. Last one. This is probably the hardest one that you're ever going to get. And the only reason is because PO4 is negative 3 and Ca is plus 2. So it gives you it's the most crisscrossing, or I should say this compound has the most atoms of a crisscross compound that you're going to deal with. Ca is plus 2, so it goes there. It's going to go with OH, which is minus 1. And then H, because it's positive, goes first. And it's going to go with PO4, which is minus 3 as a group. So again, there's 3 CAs here. Don't just assume that there's going to be 3 here. You have to re-crisscross these every time. So Ca with OH, the formula is going to be CaOH2. And then H with PO4 is going to be H3PO4. Okay, and then to go back and balance, unfortunately, these numbers will get large. You'll have to put since there's 3 CAs here, you have to put 3 there. You have to put 2 there. That'll give me 12 hydrogen, so it's a 6 and a 1. It's basically the same balancing that we did on the other side, but reversed because the compound is reversed. So that is how you do neutralization and hydrolysis. This is our second to last topic in acids and bases. This should also hopefully help you with the double replacements and with the electrolyte sheets, because you're doing a lot of this on those sheets and people were making some mistakes there. So this was more examples of how to crisscross things. And if you have any questions, just message me on Remind and I can answer them for you.